We're going to go ahead and get started. It's right at 12:01. So thank you, everyone, for attending Unlocking Microgrids, Strategies for Effective Cost Management of Your Electrical Infrastructure. So we have a pretty good panel lined up for the webinar today, and it will last approximately 1 hour. Everyone is on mute right now, and we will have a question and answers at the end that you can send via the webinar on your computer, and at the end we'll be able to raise your hand by hitting *9, and we can take a question. So we have a pretty good topic, and with that I'm going to turn it over to Peter Asmus from Pike Research to get started on the beginning of our webinar.
John. I guess I'll just briefly introduce myself before I introduce the other panelists. I've been covering microgrids here at Pike Research since about 2009. We've been developing a lot of different reports and breaking down the market into different segments. And we actually just released earlier this week a report called the Microgrid Deployment Tracker, which is our attempt to create a working database of plans proposed under development and operating. 13 there, we got 23. Yeah. Yeah, I'll see you around. About 3 gigawatts of projects, and 2/3 of those located in North America. So with that, I'm going to now introduce all of the panelists. First, Rajan Chudgar is the Vice President of Smart Grid for Power Analytics. Raj joined Power Analytics with extensive experience both in the wholesale operations and market, as well as in the retail energy space. He's also led numerous client projects covering all aspects of system and life cycle development, ISO development, and wholesale energy business solutions. He has spent more than 15 years in the electricity market and utility business with a focus on software development, renewable generation, market strategy, and of course, smart grid solutions. Started a career as a research engineer at ExxonMobil, and also worked at the Electric Reliability Council in Texas, served as manager and then as principal at the global engineering consulting firm Black & Veatch, and was a manager at energy consulting firm Fortegra and the Structure Group. He also holds 6 U.S. and 2 international patents. Next, I'm going to introduce Rajan Chudgar, who has 25 years experience in entrepreneurial consulting, business development, sales, marketing, political, and research roles. Key consulting clients have included Austin Energy, Tropos Networks, the City of San Marcos, Extreme Power, the Town Street Project in Austin, Texas, and Sharp Labs of America. He's a nationally recognized innovator in energy. And John is now pioneering new business models and consumer engagement strategies with his new company, NextWatt Solutions, a consulting and energy services company that leverages innovative distributed energy technology to create industry-specific solutions for commercial building owners. John is also a co-author of the 2011 industry bestseller, The Advanced Smart Grid, Edge Power Driving Sustainability, which documents the grid of Austin Energy at the Town Street Project. The smart grid is called the Advanced Smart Grid, far away the best book yet about the smart grid. Next, I'm going to introduce Jim Waring, who is the Executive Chairman of Cleantech San Diego, a not-for-profit formed to stimulate the creation and expansion of new technology businesses, a cluster in the San Diego region. Prior to co-founding Cleantech San Diego, Waring worked for Mayor Jerry Sanders in the City of San Diego, the Deputy Chief Operating Officer for the Land Use and Economic Development. He currently serves as a mayor's appointment to the San Diego Housing Commission, and in 2012, this year, Waring was appointed to the California Transportation Commission by California Governor Jerry Brown. So with that, I'm going to let Jim Waring take it away and sort of give an introduction to what is a microgrid. Yeah? Okay, Peter, thank you very much. I appreciate the opportunity to
title was the quote, taming the beast. And I think as we'll learn today that this beast has been tamed or at least been identified. And in the conversation today, we'll learn a lot about the opportunities as well as the challenges of microgrid. Now, if you go to the first slide, introduction, what is a microgrid? I think this really summarizes the essence of the opportunity, because these are small scale that are designed to serve a particular purpose, as shown here. But more importantly, they provide a great deal of flexibility. They're very efficient. Microgrids have a variety of power generation sources that can be used both locally and, as noted, can be connected to the larger grid. In fact, most microgrids are connected to the larger grid, the utility grid, which raises issues and challenges that I would like to get to later. But the key point here is that they're flexible, they're varied, and they're very scalable. If you go to the next slide, which continues with what is a microgrid, as you can see, with a microgrid can accommodate or accumulate a great deal of information because it does have a variety of power sources. So the key to a microgrid is the data center, the collection of the data from the different production sources, the analysis of the data, and the response. So they have multiple levels of services, of generation, and of storage. But the key operating element of any microgrid is that the grid has varied units of production. These units of production are matched with demand, are analyzed by both the operator and then most importantly the software in order for maximum efficiency. Now the next slide gives you an example of the UCSD microgrid. And I'm sure in the discussion this morning there'll be a number of references to University of California, San Diego's microgrid, which is one of the most robust and certainly a major testing microgrid for what works. And what I want to draw your attention to here is look at the various units of production, the complexity, whether it's natural gas or solar or wind or chilled water. Each of these units of production produces different amounts of energy at different times, which is then used on campus. In fact, on campus at UCSD, the microgrid has the capability to produce upwards of 75% of the entire power used on campus. But as you will note, and I want to point out again, if you look in the lower left-hand corner, the grid is connected to the utility, both in terms of power in, and then in the upper left-hand corner, power out from the system. The next slide shows another schematic of a microgrid at the Consortium for Electrical Reliability Technology Solutions. And yet again, you will note the multiple levels of production. Look at all of the different places where energy is either produced or distributed. And the key to microgrids, again, is the balancing and the measuring of these various sources. And once again, you will note, as shown in the center there, that this microgrid is connected to the larger utility grid. So as I turn this over to Raj for implementation, I want to just leave with a post-Hurricane Sandy question. We know that microgrids can be built, and we know that they can be managed to provide cost-effective and varied power. We also have to accept and are excited about the fact that all things being equal, the number of microgrids will increase dramatically in the years ahead. As Peter noted earlier, there are already 3 gigawatts of production, and I believe we've only just turned the corner. So this leads to a very interesting question, because post-Hurricane Sandy, there's going to be a lot of discussion about grids on the issue of reliability and the hardening of grids. So a big question for our industry, if we're going to maximize the exciting potential of microgrids, is where will microgrids fit into this discussion? Given the multiple sources of energy production and the relative small size of a microgrid compared to the utility, can microgrids become part of the solution to calls for post-Sandy system performance and reliability. So with that, I will turn it over to Raj, who will talk about implementation challenges.
Yeah, thank you, Jim, and thank you, Peter, for moderating this session. As many of you guys have read and probably heard, Peter is one of the experts in this industry that really, through Pike Research and he's now with Navigator, gathered probably the aforementioned expertise and understanding around both development and capability and, frankly, what's going on in this industry. And Jim and his group with Cleantech San Diego have been working heavily in understanding and providing, if you will, the capabilities and why we should put renewables and other things like microgrids in places so that, in fact, we can create a more sustainable future. And that's brought into light, as Jim pointed out, even more so with what's happening in Canada. So what I'm going to do for the next few minutes is really talk about why is a microgrid important and some of the interconnection or implementation challenges that we've seen both at a micro level and at a more macro level. So to step back first, why are microgrids important? So as Jim pointed out, right, one of the reasons why we're looking at microgrids are going to become more and more of an opportunity now is we've upgraded our infrastructure from a holistic standpoint around the world. One of the predominant proliferations has been advanced meter technology, so AMI. A lot of the utilities have also upgraded their communication backhaul and the communication grid. We've seen the start of the implementation of electric vehicles, and there's a lot of other infrastructure that's being put in place, including distributed automation or distribution automation and substation automation that allow microgrids to become not only a more effective part of the economic mix, but also a part of the reliability mix. In addition to that, we've seen significant advancements in IT hardware and energy-consuming devices, both from a communication capability, i.e. being able to provide things on a per-second basis as opposed to a per-minute or per-hour basis. And what this is doing is it's driving, if you will, the opportunity for us to have better infrastructure and the capability to manage ourselves. The converse to that is we're starting to see a lot higher energy consumption due to IT, if you will, data centers and various other devices that are out there that are driving up demand. And so in addition to that, the other force that's coming in is resource adequacy. So we see it all around the U.S. due to various EPA regulations and nuclear regulations, et cetera, the potential sunset for a large number of bulk generation. So this is causing, if you will, a convergence of an opportunity where microgrid and distributed generation become or move to the forefront of our work. So for many organizations, power by far is the last or the largest operational expense, and unfortunately, it's the least managed commodity. So if you look at whether you're an office building or a data center or a hospital or any number of facilities, you know, the opportunity to manage power appropriately, both from a generation source perspective as well as from a demand source perspective, becomes something that will then drive operational excellence, will drive capital expenditures, and frankly will drive the business forward. If you go to the next slide, one of the things around driving operational understanding of power is understanding how you would take a facility and campus that's grid-oriented or grid-connected capability and turn it into, if you will, a microgrid. And to be very clear, a microgrid doesn't necessarily mean that it's always disconnected to the grid. A microgrid very simply means that you have the opportunity to appropriately disconnect from the grid if there is perturbations or an understanding due to economic or reliability reasons that you want to do that. So what we talk about when we talk about microgrids are there are generally 4 different processes of a campus, a facility, an owner that might want to operate, if you will, this whole microgrid. The first and foremost, as Jim pointed out, is like UPSC. It is operating like a microgrid, but it's also connected to the utility. Now, you might do this to minimize your current consumption. You might do this to take economic advantage of what's going on, or you might do this to have a N+1 reliability factor in the sense that if you do the utility, you have the opportunity to use your critical facilities up and running in case there is that type of emergency, i.e. Sandy or something similar like the blackout that occurred in San Diego back in September. The other processes beliefs that we have around microgrids or structures like microgrids are, how do you separate from the utility reliability, right? So you might do this again for economic or for reliability reasons. And then once you are separated, how do you operate in a separated node so you can consistently provide the electrons necessary to supply, if you will, power to your computing devices that are within your scope, or if you will, your area of control. And then finally, when the utility comes back online, the appropriate measures that you need to take to do that. So these four processes, for all intents and purposes, have a whole set of, if you will, components around them that deal with how you would manage this from both an IT and a personnel perspective. So you have to plan what you're going to do, and either it's both a planned or an unplanned outage, if you will, i.e. moving towards this type of microgrid. And then you schedule it appropriately, you execute based upon any of your schedules or operational procedures, and then based upon what you're doing, there's almost always or inevitably going to be some sort of a settlement to reconcile where those electrons came from, how much fuel costs you had, how much electrical costs you had, et cetera. So while this sounds very complicated, it actually becomes very straightforward if you move to the next slide on how you actually manage this from an overall infrastructure perspective. So from operating a microgrid while connected to the utility, the focus is generally economic. So again, there's a pictorial example on the right that shows you have a general point of common coupling, you have some sort of switch, and then beyond that, you have any number of loads that are essentially connected to the microgrid with certain generators on there. And so underneath this, there's four different possibilities. Generally, there is no local generation. So in this case, you're connected to the grid in general. You might have some demand management or demand response. And so you're utilizing that demand management response to appropriately, either in an automated or manual manner, reduce your economic or your electrical footprint and thus gain some economic value for your connection to the grid. In the case that you have some local generation running, now you potentially can leverage that with demand management, but you're still importing some power from the utility, again, similar to CFP. But now you're trying to operate in terms of what's the maximum value of my facility based on my local generation, with notwithstanding the fact that I'm still connected to the power system. Then you might have enough local generation that exceeds your local load, right? So in this case, you're now providing power flow back into the grid, so this is exporting to the utility. In this case, there's a number of other factors you have to consider, for example, safety factors back to the grid, as well as export tariffs on what type of revenue base you use for exporting that power back to the grid under various number of circumstances. And again, all of these would be considerations on how you operate this microgrid. And then finally, there's the opportunity that we're starting to see more in the military and various other federal facilities, which is essentially termed net zero. This is the understanding of matching local generation with local loads. So in essence, you're at a net zero compared to the utility. Now, the conversation that's being had in the industry is, of course, you can't do a net zero instantaneously all the time. That's due to the fact of how grids are connected, but instead it's more of the accounting for electrons and accounting for the carbon footprint. The other operation that's probably important just to give people a perspective of how and what are some of the challenges of microgrids are, how do you operate the microgrid while separated from the utility, right? So the pictorial graph here on the right shows that you've essentially opened up your static switch, so now you are not or disconnected completely from the grid, and you're now operating, if you will, in an isolated zone. The primary concern here is, do you have enough local generation that can support your critical load, and more importantly, sustain that critical load over time? How long do you have in this microgrid mode before various critical facilities collapse? What additional loads can you bring on in order to provide, if you will, additional power support? And this is direct implications to, for example, what exactly happened with Hurricane Sandy. We had some local generation. We had loss of the grid. We then had local generation and ETS come on to essentially substantiate critical operations. And then there were various entities that were thinking about, well, what about utilizing some of that excess power that I have on those generators to bring on other facilities? The problem that they think is not understanding that additional load. How is that going to work from a dynamic facility standpoint? More importantly, how is that relational to, if you will, the how long I can operate that microgrid. So this is kind of from an implementation challenges standpoint. What you have to really look at is the bifurcation of not only when I'm in a grid connected mode, but also in a separated mode and all those transitions thereafter. There's a number of different issues to think about. There's various ones with voltage, frequency, power quality, even current and power factor in general. And this has everything to do with balance and balancing your current appropriately with the grid in general to the extent practical, or if you're separated into different loads. What makes this more complicated is when you have renewables and more appropriately intermittent renewables like EV and wind. These types of renewables are not necessarily predictable in nature, and in many cases the forecasting for these are inadequate, and so you then have to add additional dampening factors like battery banks or capacitor banks, etc., to, if you will, manage the swing inside of these due to these renewables on your local facility, so that in fact you can substantiate or still provide the load with the appropriate power that you need. Resynchronization with utility grid can be, and resynchronization also means disconnection from utility grid can be difficult, especially if it's unplanned. So as an example, when Hurricane Sandy essentially hit, a large number of facilities essentially immediately disconnected from the grid. Now, this connection is quite easy. When do you reconnect and how do you reconnect can be one of those interesting conversations that you have with utilities, state factors, etc. The other interesting conversation that's being had or discussed in the industry is if you have these sustainable microgrids at the local level, can you utilize the black stars if you will to resource this grid? And so a lot of these conversations are now going to come to light with some of the, if you will, finally, you see a lot of interconnection standards that are being developed. A number of those are being driven by IEEE like 1547 and a number of other groups like IEEE, etc. A lot of these standards are, now that I'm starting to see the proliferation of microgrids and distributed generation, how do I appropriately have those conversations and how do I standardize the data and appropriately so that I can manage these utilities in a stabilizing manner with the grid appropriately. So with that said, and with those implementation challenges, I'm going to introduce John Cooper, who will talk more about how do you take these implementation challenges and provide some potentially economic value and what are some opportunities there. John?
Yeah, thanks, Raj. I enjoyed your presentation. Thanks also to the organizers. This is a great topic, and it's fascinating for me now to see microgrids coming into their own. I think especially with events like Sandy, the question reliability, and my hope is it will cause everyone to look a lot harder at microgrids, and we'll be talking a lot more about them going forward. Just a little note for everybody on the call. I urge you to take a look at Ford's blog yesterday, my little Ford and Co-op City. There was a section of Brooklyn that stayed online throughout Sandy, and this blog represents you take a look at how that was able to stay on. If you want district energy, and I would say some form of microgrid. Anyway, if we want to go to the next slide, we're going to talk about the topic of co-optimization. This is a term we hear a lot more of. And really, I reflect back on the work I did in 2009 with the Concrete Project, where we talked about the upcoming transition to introduce a lot more of these new technologies, distributed technologies, into a rapid static system that can run under here and orient around the grid and the needs of the grid. And so when we look at co-optimization, we look at the need to modernize the grid and optimize the grid, what we call smart grid. Is from the grid perspective, the ISOs and the operators are looking at needs like enhanced flexibility and control, certainly improved reliability like we talked about with Sandy and what's going on down here in Texas and ERCOT, and greater economic resilience. And the way I look at it, microgrids are a great potential solution to start to manage the increasing complexity, what I call out on the edge, out near the end of the network, where these smart meters are, and now we start to look at moving back to the distribution meter level. How can we manage using resources other than the central resources provided under the grid there now? So when we look at
co-optimization, we think about grid system needs, but we also think about the needs of individual accounts, energy users, which could be industrial, commercial, residential, etc. The needs of the actual structures of the buildings, and the needs of microgrids. Now, microgrids are looking to increase advanced energy, building energy management systems. Some of their optimization challenges include industrial process management systems and so on. Now let's take a look here at the stakeholders. When I talk about individuals, as I said, I'm really talking about the leaders at the leader level. When we talk about the emerging industry associated with buildings, and we're talking about energy management systems, we're talking about energy efficiency, EFCOs, building management systems, distributed generation providers. Then we move on to microgrids, which is optimization at a regional level, military bases, campuses, etc. And then companies like Power Analytics that are working with microgrid software and services. And then we move to what a lot of the discussions about, which is optimization on the grid, smart grid discussions of different types of utilities and regional optimization. And so what we could say is co-optimization is a term we can use to talk about how we're going to blend these interests over time. And so we're going to go to the next slide. Another way to look at it is the contemplation of a new business model, where we're going to be transitioning away from this 100-year-old model where we looked at meters on buildings, the utility grid for distribution, transmission, and then the ISO to manage from a regional level. Fairly straightforward, even, notwithstanding its incredible complexity. So now we move to an integration of really what I might call an emerging energy economy, where we have multiple players, multiple stakeholders. And each of these are going to be moving to improve, from their perspective, their optimal participation. So from the microgrid perspective, now we have individual motivations of those within the microgrid, and then they need to interconnect, as Raj was saying, with the grid. So we can go to the next slide. As we look at microgrids, I thought it would be helpful to look at the building optimization models that we developed at NextWatt to talk about the emergence of these new capabilities out of the ends of the grid network in terms of distributed energy at the bottom, stage 1 there with energy efficiency, but also distributed energy, distributed generation. And as that situation matures, we start to look at energy management systems. Now, microgrid contemplates starting with at an aggregated level at a whole region. And the next step in the maturity curve for a microgrid is to connect, to determine how they will interact with the grid. And then finally, we get to the optimization model where they will determine whether they take power or provide power through what we call demand action. I'll explain that a little bit later. Or they act within this realm we call demand response, where they can actually take the power requirement down to the grid. So if we go to the next slide. I pulled a maturity model that we developed that was in Chapter 7 of the book, where we talked about this emerging consumer that will move from a passive and unaware state of the consumer up to a prosumer that's independent and ally. And as we reach the co-optimization stage, we're getting aggregated buildings as well, microgrids operating, and the consumers operating, and potentially the systems within buildings operating all in conjunction to support their goals. So let's go to the next slide. In summary, I think what I would say about co-optimization is that we need to understand that these systems will technically operate and manage the conditions inside the microgrid, but also manage within the context of the larger grid. I find demand response fascinating because
scale the power on request from an operator, either for a reliability condition or for an opportunity of the operator to have an economic event. And the prevailing wisdom and demand response is that we will use it when we need it, and it's driven by the utility perspective. If we go to the next slide, we will introduce the concept of automated demand response, or auto dealing. What we just talked about, the difficulty of demand response, is called an active demand response, where it's characterized by a manual signal and subject to really human intervention. And we're moving now with ADR to an automated demand response. So we have much greater potential in innovating with different devices and actually automating the signals. And as I said, go to smart meters and to other devices just to down the algorithm. So this demand action, in the Cleantech project, we talked about how we're going to integrate these different distributed energy resources and the emerging complexity. And we suggested, we're not just going to be as low, hopping up the edge. We're not only going to be retaining power, we can actually provide power. And so introducing the concept of demand action was to suggest that we would have resources like microgrids powered by all these different emerging technologies to turn off the power from the other direction. And we introduced this concept of incorporation. What does it look like when we're providing power out on the edge? And if you go to the next slide and roll it all together, I think we need a far more sophisticated understanding of the whole concept of demand response. So it's what's oriented around curtailment and really talking about how we can start to look at these as demand-side resources in general to encompass both the demand action and the automated demand response. And so out at the Peter level, we have the opportunity to coordinated action communities and also microgrid. And the idea is, I believe, that we'll see those used increasingly in peak power situations, but also for power reliability during disruptions, like hurricanes and Andy. I think that the message that I hope to provide here is that we're going through a transition from a grid paradigm to a much more complicated paradigm in some ways of lots of parties, but also we're taking some complexity away from the grid by providing new types of solutions and resources. And so with that, I think I'll turn it over to discuss about microgrid publishing.
Yeah, thanks, John. And from a perspective of what John was talking about, right? What we're seeing in the industry is we're seeing maturization, software and hardware, and frankly, addressing challenges due to the fact that we're seeing more and more circumstances that require these more mature systems in order to handle these new market factors, new distributed generation capabilities, and frankly, the reliability that people are wanting to expect and want and needing to expect. So one of the things to kind of conclude this session that we talked about is, there's a lot of hardware out there that is extremely important to have as far as the scope of what real facility or capability are you want to do. However, integrating that hardware appropriately at the customer level into a microgrid energy management software system is critical in order to get the full effectiveness out of what you're trying to do. And so some of the traits are developed, we want to be able to develop and efficiently manage, or you might want to develop and efficiently manage your diversity of energy generation, electrical storage, metering, demand management, and frankly, any of the capabilities or devices that you have on the facility. And so that's a large order. Being able to integrate all of that data together, being able to optimize all of that data together. And again, as John mentioned on the maturity chart, you start off with, if you will, very simply putting devices, energy generation, and energy efficiency. You move towards energy management, and then as you move up and up, further up the scale, you eventually get into optimization. And so you optimize based on demand management, this would be demand response, including load shifting, load optimization, load shedding, etc. You manage and optimize based on demand, distributed generation, of what assets you have, including storage. And then finally, you look at things, some of the parameters that you would look at for optimization are not only reliability, but now you're looking at economics. And this could be capacity markets, these could be ancillary service markets, these could be energy markets, or this could be just utility. And so all of those different factors that are both within your, if you will, facility, as well as data that would be coming in from outside, i.e. the utility, the independent service operator, or even weather, all related to how do you co-optimize the facility. If you go to the next slide, some of the basic requirements that we talk about, things that we have seen folks need or require as part of their energy management solution are real-time energy management based on accurate analysis and predicting power problems on the network. So again, it's a very long way of saying you have to have a very accurate or high fidelity model of what's actually occurring in your system in order to appropriately take action, whether that's on the distributed generation, demand management side, et cetera. A comprehensive understanding and reporting of their energy usages and costs. This has everything to do with measurement and verification. There are a number of standards out there, whether it's the ICSP or standards, IEC standards, et cetera, around measurement and verification. All of that has to do with comprehensive understanding and reporting of how you're operating at the time. You absolutely need forensics with the understanding of the ability to drill into if there are any issues around your system and you want to have a forensic at a sector neutral level. This is generally the case because of how complex these systems start to get. You want to make sure that when you do have issues, you're able to decipher the root cause quite rapidly and then appropriately take action. You want to provide automated power information. A lot, as mentioned before, there are a number of standards that have either been passed or in development around how you actually communicate data and more appropriately power data between utilities and individual users or between various pieces of generation or demand within a facility, etc. You want to optimize your maintenance, training, and frankly, how you want to run your system. One of the key attributes we find with almost every system is operators want to be able to do things, but they want to be able to, if you will, make sure they're doing things the best way practical. And so what they've desired is an online simulator. So what if these circumstances occur? What should I do? And so having that capability with real-time data is generally important for how you know how to optimize it. So going to the next slide, this is just very simply a depiction of a type of architectural scenario. To the extent practical, you want to have some sort of middleware or a service-oriented architecture framework. You want to have the capability to call various devices or integrate various devices with hardware and software and analytics so that you have the most comprehensive solution. But at the same time, you're not necessarily buying something that does everything from the beginning. So if you go to the next slide, another way of looking at that IT pictorial model is looking at it more from a computer-oriented model, i.e. a computer chip. You want to have the capability to provide optimization appropriately at the microgrid or at the macrogrid level. So there's a lot of different inputs that would be taken in, right? Regulatory, commercial value, reliability, generator, if you will, respond to nameplate capacity, load capability, etc. And then based upon all of these different inputs, you want to be able to output your optimized plan, your optimized scenarios so that if there are unplanned activities, you're able to respond appropriately. In general, what we talk about in the next slide is at the facility level, we really need to have a master software control. Now, there's no question you can distribute that amongst multiple different devices like distributed generators, distributed loads, distributed storage, demand management, etc. But the reality is, if you don't have a master software control solution, you will lose efficiency at each of these individual tools, which will cause a less than optimal, if you will, opportunity package. So finally, to kind of wrap up where we are and what we talked about, if you move to the next slide, there are a number of different ways to look at how microgrids, the challenges, the opportunities that we have in light of what occurred with Hurricane Sandy and a number of blackouts that have been occurring throughout the world, actually, it comes to fruition that having the distributed generation, even if it's simply diesel backup generation, and having the opportunity to utilize that on a more pervasive basis where you're able to claim value from your infrastructure grid can have a profound impact not only to reliability but also economics. And so the final point I would make is there's lots of claims out there on what things can and can't work. My advice would be, talk to some of the industry experts. We heard from a few of them today. NextWatt Solutions, Pike Research, Cleantech as an example. There's a lot of information out there that folks like them can provide that helps people understand what they should do and why they should do it. And more importantly, it's third-party advice that frankly we couldn't have. So with that said, I think it's about 45 after. I'll turn it back over to Peter for some concluding remarks, and from there we'll talk to you.
Okay, thank you, Raj. So here are some conclusions before we get into the questions. Microgrids, they offer the ability to optimize infrastructure, cost availability, and energy demand. These are some of the classic examples of complex economic optimization that microgrids can help create. The mixed asset approach, which we at Pike Research believe is very important, is uniquely positioned to take advantage of reliability in commercial events with real-time constraints and provide a variety of organizations with more security on grid management and long-term stability. And I'm sure we're going to be talking about this a little bit more in regards to Hurricane Sandy. There today are regulatory, commercial, and political decisions being made that are impacting this market. And as individual state government policies are different, I think it's interesting that Connecticut is the first state to actually pass a microgrid law earlier this year due to two storms last year that led to major power outages. And I have a feeling, given this most recent storm, we're going to see other states, particularly along the East Coast, following suit. Of course, what makes this market difficult is that the regulations really vary immensely by state and region. Things like net metering policies, utilities, revenue decoupling, time of use, pricing, all of those things actually impact the economics of microgrids. Often the costs associated with distributed generation do not take into account the lack of transmission infrastructure to support those sources, and also utility regulations, individual utilities, whether they're investor-owned utilities, municipal utilities, or even rural cooperatives. All of that must be taken into account. The future of demand response, utilizing mixed asset and auto-DR capabilities in a microgrid setting, is really one of the most promising aspects of this market. And I would say the main change I've seen in terms of the way people are looking at microgrids over the last 3 years is that it sort of started more with a reliability focus, and over time the shift has been much more, or equally so I should say, to economic optimization. Let's see, next slide. Here, I guess, as a final conclusion, distributed generation will continue to be an effective energy solution under certain conditions and for certain types of customers, particularly those looking for emergency power, uninterruptible power, and as well as efforts to reduce emissions and diversify risk. But without a state-of-the-art power management system solution, the challenges in the power industry with distributed generation will become nearly insurmountable and unsustainable. So we have received some questions already from the audience. The first one I have here is, I guess I'll start with the first answer. How big is a typical microgrid? I get this question all the time, and unfortunately, there is no precise answer. I mean, the sort of the beauty of a microgrid, if you will, is that it can be almost of any scale. From Pike Research view, of course, we don't view a single home with, let's say, a solar PV panel and maybe a battery. We don't view that as a microgrid. We view that as a hybrid system. In our view, there has to be some network. So usually, even more than 2 customers, at least 3 customers, if you will, or 3 large loads comprising a microgrid microgrid, but in our tracker, I'd say the UC San Diego microgrid is 42 megawatts. That's kind of at the upper end of actual operating systems, although I've heard of projects envisioned as large as 200 megawatts, which I would say is sort of, I don't know if that's the ultimate, the ultimate large microgrid, but we are hearing talk of that, and there are no microgrids, at least to my knowledge, that are that large. But in terms of how small they can be, the smallest microgrids are literally kilowatt range. I'd say the most extreme example would be mobile tactical microgrids for the military, which is sort of a separate category. They are not grid interconnected, and those may be only 2 to 5 kilowatts. These are microgrids that can be built in a day or so, might have a solar panel backside, and would be like deployed in Afghanistan and places like that could actually literally be moved around. But I'd be interested to see if anyone else on the panel would want to say. I mean, average microgrid, I would say right now, in the lower megawatts, or below 1 megawatt might be a good number. I don't know. Does anyone else want to chime in on what's the typical microgrid? Anyone else on the panel here?
Yeah, Peter, from what we've seen is exactly to your point that the majority of microgrids that are out there are in the low megawatts, so 1 to 3 megawatt type of range. You're absolutely right, forward operating facility, or if you will, remote cell tower facility. These could be considered small microgrids. In those cases, they're almost a compact solution that's put out there that can be grid connected as necessary. But as you go to higher and higher, if you will, levels, and the more complex the microgrid gets, the more value, if you will, for additional capabilities in the facilities that are necessary to sustain the microgrid.
Yes, that was true. Earlier in this, we saw a slide, for example, from the CERT system, which I would say, is more applicable for smaller microgrids, simple microgrids, or ones that is not capable of economic optimization, like it used in San Diego. But for some people, that's maybe all they want is sort of a reliability only focused model. And I think as the market matures, people will be sort of differentiating between microgrids as to sort of what their primary purpose. Of course, there's some microgrids that have zero renewable generation. They're more CA, focused on combined heat and power. And then there's, ones that are more focused on renewable integration. So, it's just a very diverse, modular universe of microgrids, but I guess that's supposed to be the appeal of that.
I think I'd like to add a point. I think
Sure.
the proliferation of distributed energy, that question becomes a real challenge, because what we're seeing right now is the emergence of microgrids, and those campus environments would have a compelling use for them. But as the technology like power analytics and control systems become ever more sophisticated and capable, they're going to offer at the edge what I call ends of the network, an opportunity to control and contribute from a different perspective. And this may be at the building level, it may be at a small district level, like you said, an aggregation of 2 or 3 loads, or it may be up at a significant campus level, like a military base or a college campus. But the idea is that we're going to have 2 levels of control, one central, the typical grid control, and then another at the micro level through software like power analytics. So I don't know if we'll see a different side. Right now we have an emergent phenomenon, but I think it's going to be very wide down the road.
I think, and I guess I should say we should identify ourselves. I think that was John Cooper, correct?
Yeah, I'm sorry. Yeah, this is John Cooper. I've actually heard the term microgrid mentioned, but not to belabor the point. I think the whole idea of a microgrid is in contrast to the macrogrid.
Right. I've also heard mini grids, nanogrids, and of course, even definitions of microgrids, which we didn't really get into. There is an official DOE, Department of Energy definition, but that definition actually excludes what we call remote microgrids, which we aren't really dealing with here, which are more system asking, I'm wondering if microgrids could have eliminated many of the problems with natural catastrophes. And then the second question, how do microgrids fit in with large utilities? So I guess I'll start again with that one. In terms of natural catastrophes, I actually had many media requests here in the last day or so asking this question. And unfortunately, I was actually in South Korea last week talking about microgrids there, so I haven't been able to track performance. But I do know, and I have a blog coming out today, that in a catastrophe Japan, with Fukushima, that there was a microgrid actually located right next to the nuclear reactor, which ran continuously and seamlessly through that disaster. It's called the Sendai microgrid, S-E-N-D-A-I, I believe is how it's spelled, and I'm sure if someone Googled it, you could find that story. But I would say in terms of with large utilities, in what we've seen is in the United States, most microgrids are coming from customers, like in college campus. But we do see more interest in microgrids from utilities. And to John Cooper's point, for example, San Diego Gas and Electric is developing a different microgrid that is actually, it's actually coming from the utility, and it's because it's on a remote feeder line. I believe it's in the high desert. It's called Borrego Springs, and the issue there is these remote feeder lines. Is a microgrid more cost-effective than other smart grid solutions, or even building a whole new substation? In this case, there's also a lot of customer-owned solar PV, so the utility is trying to figure out what if we develop a microgrid, but a lot of the generation we don't even own or control. How would that all work? It's also looking at demand response, etc. So I'll say the last thing I'll say is when I was in South Korea, it was interesting. Their view of microgrids was much more on high-rise buildings, and if you look at the whole South Korea, you can understand that perspective since it's such a densely populated. But they were looking more at, I would say, sort of high-rise buildings as aggregated with microgrids. But there, the utility was a partner. So some of the regulatory issues that get in the way here with customer-owned utilities, they weren't an issue there. So I'm just wondering if anyone else wanted to address the Hurricane Sandy issue, because that seems to be the buzz right now. So anyone on the panel, please identify yourself before you make this comment.
Yeah, this is John. I saw a letter yesterday from the governor of New York to the two major utilities in New York challenging the whole idea of reliability, and I think, and the consequences of not having a more robust outage management strategy. And so I suspect that there will be significant ripples from a storm like Sandy that hit, coming on the heels of Hurricane Irene and the derecho. And that will see this whole idea of outage recovery be complemented with some sort of plan B that microgrids could really fill in and provide sustenance for critical facilities, anticipating that there will be another storm in less than 100 years. We're going to have storms like this, and so I anticipate that we'll be rethinking the whole idea of outages and outage recovery to include some sort of outage prevention through things like microgrids. This is Rajan Chudgar, and a couple of things to add on. There's no question that the capabilities of microgrids to increase reliability if designed and operated correctly. It's also true if not designed and operated correctly, that you have the same consequences of the grid. So one of the things to be very careful about is it's not a silver bullet. It has to be appropriately managed and operated. But agreeing with John, it definitely could be one of the both fixes, or if you will, outcomes of Hurricane Sandy. As we saw back in 2003 when we had the outage in the Northeast, one of the manifestations of what we learned out of that was we need to identify and put in a number of measurement devices that would prevent chain reactions from occurring. I foresee a similar type of investigation occurring where utilities will have to come up with new methods to essentially interrogate into the current macro grid, i.e. making mini or microgrid, that would then allow for, if you will, critical infrastructure to stay up and running. The other part of the
question on utilities and utility provided microgrids. Actually, what's interesting about them is more around the world. So in countries like Africa and Asia, a number of the utilities actually sponsor building microgrids. And so, again, it's similar to UCSD with Pareto Springs. To the extent practical, where there is unreliable circuits or feeders, etc., it many times is more cost-effective to put some local generation there and appropriately have it designed to be a sustainable microgrid long-term. And so a lot of people are looking forward to that.
Thanks. Should we go, if anyone else, if we're done with that question, let's go on to another one here. This question says, utilities are required to demonstrate power availability and calculated peak load. Are we reaching a point where microgrid power can be credited to this regulatory environment, reducing some redundancy? Well, I guess I'll take a first stab at that. I would say I don't think we're at that point yet, but I think we're getting closer. In fact, when we at Pike Research, we did a report called Utility Distribution Microgrid, which was sort of where we decided to start looking at the microgrid market more from this utility vantage point. What we heard from utilities, especially investor-owned utilities, is that the biggest issue for them wasn't so much technology anymore, although because utilities tend to be conservative, you know, they're trying to validate different control systems, et cetera, but they were saying the main challenge for them is how to justify investing in microgrids within the 3-year rate-based business model. Obviously, if you're an investor in a utility or if you go to a public utilities commission, you ask, you know, for X amount of money, you're supposed to sort of have an estimate of what the benefits would be. And so what I heard from the investor-owned utilities like San Diego Gas and Electric, American Electric Power, was, you know, they weren't there yet. They had their microgrids that they were failing had not operated long enough for them to collect enough data, and, you know, they also were just worried, you know, what if we test microgrids and the power goes out, you know, on our obligation to serve. So I think, you know, that we're getting closer maybe to where people can sort of include this, the value of a microgrid. And before I turn over to other people, I would urge, there was a study by Lawrence Berkeley National Lab last year that attempted to quantify the benefits of a 10-megawatt feeder line microgrid to the owner, the developer, the distribution utility society, and we actually did some of those numbers in our report, but that was for the first time I've seen actually people trying to attach numbers. The challenge with that is with a theoretical microgrid, it wasn't actually one up and running. So with that, I'm wondering, does anyone else have any comments about this idea of, you know, how to credit the value of a microgrid within the sort of existing regulatory system?
This is Raj. I actually helped my previous wife on a couple of studies with utilities around creating microgrids on feeders for remediation of peak power, et cetera. And, you know, there's a couple things I would say. First off, some of the barriers. The barriers really have to do with, as Peter pointed out, the amount of data that utilities have currently is split. And so to substantiate that type of performance to reduce peak pricing and, if you will, reduce the amount of capital necessary to increase some of these feeders, it would be a difficult conversation to have with the regulatory society. Secondly, since most of these IOUs are tariff-based and cost recovery-based, there's very little incentive in most utilities to essentially reduce the amount of capital spend because, in fact, that's what's recoverable through a rate tariff, especially if it's filed appropriately. And then third, one of the key problems with this is if it is a microgrid that is customer-owned, and for example, it's providing power back onto the grid, there's a number of safety and risk concerns that we still have to work through. And I'm not saying that that's easy or hard. That's no different than microgrids providing black stuff capability. There is definitely a position that can be taken that says microgrids are much more reliable than an antiquated coal plant that's essentially being kept on standby for black start. However, the reliability of coal plants, obviously, possibly 10 hours later, is probably much higher than, if you will, a natural gas generator that's on a microgrid. With all of that said, there is a factor around risk and safety that still has to be addressed on a more holistic basis, which I think I'll substantiate back to Peter's point, which I think we could get there, but we're not quite there yet.
Thanks. Anyone else want to comment on that?
Yeah, this is John. I just want to introduce the new term to everyone's lexicon, which would be the concept of energy self-sufficiency as a build-on to energy efficiency. And I think that's where microgrids play a key role. And with all the constraints that Raj just elaborated, based on his significant experience at ERCOT, that complex system is very leery of new technologies and new approaches because they have to run to keep this big system in balance. And so I think we're more likely to see microgrids on the customer side. That trend continues here in the U.S. Right now, the recovery, the cost recovery that Peter mentioned, and just a simple bias towards supply-side resources will mean that these demand-side resources will be, I think, slow in being recognized. Although to counter that is this whole idea of Hurricane Sandy, and they're going to need to be doing some significant things to address the inherent reliability from extreme storms. So, but I think the primary emphasis, from my perspective, is going to be on the commercial side, commercial and industrial side, where these technologies represent a really good way to shore up their energy reliability and even provide some energy self-sustainability.
Okay. Yes, I would say I would agree with basically what you're saying. I think I'm actually right now updating our military microgrids report, which in some ways the U.S. military, which is definitely out in the lead in terms of globally. There are other military agencies sort of watching what the U.S. is doing, like Canada is interested, France, the U.K., and China, but no other military agency in the world or military agencies in the world have I guess you could say an actual program for microgrids. So I think, a lot of people focus on the military, but, first, the military agencies also have a lot of contracting limitations with funding issues given the current economic conditions and proposed budget cuts, etc. So it's, I think, obviously the military helped create the internet, and we saw what that did. So I think the military is going to play a key role. But what we're seeing in terms of the marketplace right now, the leading segment of microgrids is anything that the campus, and we actually distinguish military from other kinds of campuses. So college campuses, hospitals, corporate campuses, or high-tech campuses in the United States. That's right now sort of the leading market for microgrids because, on the other hand, like for example, if we look at Europe, where one might say, wow, they've got such higher penetrations of renewables in the U.S., maybe why aren't microgrids happening in Europe? And to that, I'd say they are happening, but the markets there are different. The reliability is much higher. The feed-in tariff model is very different than the net metering model, where the distributed generation is not so much behind the meter, and they're much more interested, at least so far, in what we call virtual power plants, more sort of a aggregation of renewables through smart grid technology, but less on the need island because they don't have as much need island, and also the markets there are so interconnected. You have a Denmark that has such high penetrations of wind power, but when the wind dies, they can look to the north, Scandinavia, to fill in the gap. They can also look to the south. So it's a different market. I was going to go to another question. Would anyone on the phone want to talk about sort of globally, if you have any comments about U.S. versus Europe versus Asia-Pacific region? Does anyone want to wade into there, or should Peter go there? Yes.
Well, Peter, if I could, this is Jim Waring. Just one comment on this last point about the getting credit, if you will, for microgrids. Here's what we're seeing in the marketplace. People are concerned with spending a lot of money, I'm going to call it off-grid, away from the utility grid, to produce power if they're still going to have to pay for the cost of the utility maintaining the backup infrastructure, because it skews the economics. You're paying for your own system, but you're also paying for emergency access, if you will, or redundancy. So I know in our conversations with the California Public Utilities Commission, we really see that as the key regulatory issue, and if that can be solved, I think the development and deployment of these microgrid type systems will just explode. But until that's solved, there's going to be a lot of tension around the underlying economics.
Well, that's a perfect point, because my next question was going to be, what is the single most important barrier to further adoption of microgrids, which you already provided one answer, and I would agree with you. I've heard vendors say it's the demand charge, the utility demand charges and those things, although I've also heard creative microgrid vendors trying to get around that and figuring out ways to avoid those demand charges, you know, and I think it sort of depends also on the exact rules in different states and also the way microgrids are structured. But in terms of the other, I think, in terms of barriers, I would say probably still the number one barrier, you know, there's the technology challenges, which we talked about, but I think it's also a cultural, and we mentioned this already a little bit, of utilities. You know, there are, when we did some research on utility distribution microgrids, we spoke to utilities where in some ways they were creating systems, often due to high penetration renewables, that distribution automation type approaches, other smart grid approaches, which looked almost like a microgrid. They just maybe didn't have the islanding capability. But if you would ask them, you know, do you think microgrids are the logical evolution of the grid? I would say a lot of them would be, oh, no. You know, they still have a, they use the term microgrid for intentional islanding, and that to them is still an idea that they haven't gotten that comfortable with. You think about it, the whole idea of the structure of the grid was not to allow intentional islanding. So here these microgrids in some ways are bumping up against decades-old practices. So although this 1547.4 that was adopted by the IEEE last year is sort of a step, at least for the engineering community, to sort of say, okay, well, if you follow the X, Y, Z, you know, these microgrids should be safe, at least from a safety perspective. But I think the other issue is utilities wondering, can they control these microgrids? What if these microgrids work so well that then the end-use customers feel like they don't need the utility anymore? And I think those are some of the issues. But now I'd like to open up to some of the other people here on the panel. What do you think is the most important barrier? Is it technical? Is it regulatory? Is it cultural? I'd be curious to see what other folks have to say.
This is John. I use the term Valtone electricity to describe the way a lot of us really throughout the world think about electricity right now. It's something that comes out of through an outlet in the wall. And I think, so I would underscore this whole cultural idea that we need to move beyond our conceptions of the grid and start to think about energy in general. And there's no reason that energy from a microgrid needs to be less valuable than energy from the grid. And so I think that from the regulatory side, we have a system that doesn't embrace advanced technology footing. And I think from the utility side, we absolutely have a mentality of how does it impact my system reliability, and increasingly is it dilutive to my revenues. And so those two issues need to be addressed before the widespread adoption. But I think on the other side, it's going to be the whole reliability issue and the challenge to the utility industry that we're going to keep fixing this grid every time it breaks with a storm and not try to come back. I'd actually, this is Raj, I would actually say it's simpler than what John said. I would say the biggest barrier for microgrids are two things: education and simplicity. Education in the sense that most people don't know what they don't know, and so and we don't have a lot of experts in this industry to help people with everything from economic analysis to reliability analysis to helping people understand why it's important. It's just a basic concept of why it's important. It is profoundly divided. And then simplicity in the sense that, you go out and you just Google smart grid and you get probably close to 300 different vendors. Well, don't know what to do. And so one of the difficulties that we've seen, particularly in this space, is there is no simple, easy educational place to go to make the determination, does it make sense for me? And I think that profound, if you will, conversation needs to be had more, but unfortunately there's just not a place to really go forward without having to, if you will, read a textbook or have something that's an inherent knowledge base.
Very good. Yeah, I would just add to that. Yeah, I think one of the issues is, in terms of microgrids, is well, the smart grid, and then even within the microgrid, there's so many different vendors now claiming to build microgrids that it's true that if you were going out there and maybe you're going, well, you know, who's number one, or you know, is there a microgrid world or whatever? They're, you know, they're really well, I don't know. I could say that there's a lot of different terms, a lot of different approaches, so it's just a little bit bewildering, I think, to end-use customers. And although what I would say is it's also a sign of a growing, healthy market with lots of diversity of players and people demonstrating projects. So, you know, I think in the long run that'll be a good thing. But I wanted to, here I have another question, basically asking, you know, which utilities are the most progressive in regards to microgrids. And I would say, I guess I'll start again. I already mentioned San Diego Gas and Electric. Obviously, the UC San Diego microgrid is a customer-owned microgrid, but it is up and running, and they're also doing the Borrego Springs project. I mentioned American Electric Power has been very involved with the CERT system, which we mentioned earlier, and they're kind of experimenting with community energy storage projects, which in essence are little small mini microgrids, if you will, at the residential level. Another utility in the U.S. is the Sacramento Municipal Utility District, which should be bringing a microgrid on one of its own, I think it's its corporate headquarters online, I believe, should be coming online this year. So those are, BC Hydro is another one, more focused on what I would call remote microgrids. Globally, I'll just mention one firm, Dong Energy of Denmark, and also the grid operator in Denmark, Energetic DK. I would say in terms of Europe, they are sort of overlying microgrids and virtual power plants on top of each other, and actually have large projects above 60 megawatts, a couple of them, one running already and another one under development. So Europe, again, I mentioned it's more of a virtual power plant model, although this one project called the Cell Controller Project, I guess each cell in essence is an island, but they're actually operated, in that case, by the grid operator as a virtual power plant. But any other utilities come to mind on the panel here that you would like to mention? Or are you going a little more detail about some of the utilities you mentioned? Well, in terms of some other questions here, I think we had a question earlier about software companies that can provide microgrid control interface with utilities. Now, obviously, Power Analytics is one of those firms, and maybe Raj, you could describe a little bit more about that. I know, Raj, you also are working with a variety of other entities. I think what's interesting about this market is there's a lot of partnerships, creative activity out there. So be happy for anyone to comment on it. But Raj, maybe you could just talk a little bit about some of the partnerships you're engaged with.
Yeah, so a couple responses. Specifically with interfaces to utilities, and more particularly with the ISO and independent service operators. Really depends on what you're talking about. But here it's the questions around, for example, market information, whether it could be schedules, settlements, forecast-based information from the utility. That's normally through XML or web services. If it's more at the real-time perspective, so traditionally data, this is normally through ICTP or something similar to interfaces. You have to be able to provide with some sort of an overall software package, which gets down to what Peter was asking. In many cases, from a software perspective, to the extent that our business model supports certain areas, i.e. for us, our analytics with software, we don't support demand response per se, we enable it, but someone else generally provides the network operations center, which is or not. We would partner with folks like Viridian Energy or others that would provide the capability to participate in the market, and then we could be the underlying integration package with the utility or the ISO or the demand response player to do that themselves, and then supply us with the information of a single interface. So there's a number of partnerships that software companies have for us. We have a lot of partnerships with integrators, demand response players, hardware vendors, et cetera. And like I said, part of the problem in this area in the microgrid is, generally speaking, there really isn't a single system or a single entity that can supply all the parts. So you see a lot of people partnering to satisfy a set of requirements that generally are unique for individual customers.
Okay. Anyone else want to, I think we're about to wrap up here. Anyone else want to comment then, or any final short comments?
This is Raj again. All I would wrap up in saying is, again, thank you everyone for joining us. I believe we've listed everyone's phone and email information. I know, again, Peter, thank you for moderating this, and Jim and John, thank you for joining me in this as well. But in general, as I mentioned earlier, one of the key problems that I believe we have in this industry is we don't have nearly enough education and understanding that can help people make good, informative decisions. And webinars and some of these types of opportunities can help in a lot of those areas.
And I want to offer a shameless plug here, Raj. Our book here is a great distillation of a lot of new thoughts about smart grids and microgrids, edge resources. So I would recommend people check that out. Okay. Thank you, everybody.
Okay, thank you.
Thank you.
Okay, this will be posted online, and we do have a few more questions from people that we will be responding to individually. So thanks for everyone's time, and have a great rest of the day.